the nice thing about complex fractions, if there is anything, is just a fraction inside of a fraction. So if you understand fractions, then it's, well, I take that back actually. So we're going to look at fractions inside of fractions, but the good news is that fractions inside of fractions is just dividing of fractions. And as awful as that sounds, we've seen this before where we don't actually divide the fractions. We change it into multiplication, and then we look for any cross simplification that can occur. So using a multiplication by 1 to simplify a complex rational expression, find the lowest common denominator. It says lowest common denominator, LCD, of all rational expressions within the complex rational expression. Truthfully though, because I assume well, I guess it's multiplication. So multiply the complex rational expression by 1, writing 1 as the LCD divided by itself. These two steps right here, we've seen. This is just a very nerdy way to say what we have done, okay? So you'll see it. Number 3, distribute and simplify so that the numerator and denominator of the complex rational expressions are polynomials. That's nice. Factoring, I guess this should maybe be 2 steps. Factoring and then simplification if it's possible. Remember, since it's multiplication, we're looking for any matches in the numerator and denominator. Usually they're binomials at this time, but if they're not, that's fine. As long as there's matches, we can get rid of those, okay? But we're looking at trinomials, binomials that matches in numerators and denominators, get rid of them. You can't find matches in just the numerators and say, well, they match in the numerators, but yeah, so the simplification there at the end, multiplication by 1, again, it's more like phantom ones that we're looking at, creating phantom ones as we go through this process, and that will be kind of the process of simplifying these. Very nerdy way to show a complex fraction. Of course, we're going to be used to seeing these not just as numbers, which we've seen before from other math classes, but now a, instead of it being a, it's going to be like x minus 1. And then b would be x plus 4. Maybe c is a trinomial, x squared plus 4x plus 2. I don't know. You just never know, okay? But it could be, the good news is we know how to factor, so if they come as trinomials, we can factor it. Or if it's a perfect square binomial, something like that, difference of squares, we can factor stuff out, okay? And that's true even if we end up seeing some kind of greatest common factor. So what does it say? This is method 1, so there must be 2 methods. So the way that we're looking at here, right, so it's a complex fraction. Remember that the fraction line here is a division sign. So all we've done is taken this fraction and then divided it by this fraction. That's it. But remember, we don't divide fractions, we only multiply them. And so once we get to this point, again, if we see matches in the numerators and denominators, we can cross simplify it. Whether it's here or here doesn't really matter, but I guess this is kind of like a finished product for the math. So simplify the numerator and denominator of the complex fraction so that each is a single fraction. Again, that's what this part is. Perform the indicated division by multiplying the numerator of the complex fraction by the reciprocal. That's this part right here. So they've changed this fraction right here from c over d to d over c, but that also changes the operation. And then you look for any simplification that can occur if it is possible that it can. So some of these answers, when I was looking earlier at the assignment, they end up looking, to me, that's kind of funky, but we need to get used to that because that's this whole unit. But again, the process here is kind of the same. Take your complex fraction, change it into division of fractions, which then becomes multiplication of fractions by reciprocating this fraction, but that changes the operation. Then simplify from there. So I'll multiply the numerator and denominator with the complex fraction by this LCD of the fractions in both the numerator and the denominator. Doesn't have to be the lowest common denominator to simplify. So since it's multiplication and division, we don't really need a lowest common denominator. We do if it's addition and subtraction, but not for multiplication or division. So if we see the need for it throughout the lesson, then I guess we'll address it. But again, I'm not seeing a need or thinking of a need for an LCD situation in a division multiplication problem. Okay, so yeah, this problem right here, let's take it. Let's take these two fractions in the fraction, right? So I'm going to take the numerator here, right? So I'm going to rewrite this problem. I've got the numerator, this big fraction line right here. I'm now made red. That's the divide sign right there. And then I divide it by the denominator. So I just move it over here. I guess this is important too, but the numerator here, this fraction, which is the numerator, is always the first part of the division. which is called the dividend, which I also don't think you care about. The denominator is the divisor. That's the second part of the division, okay? So now that we have that, what we want to do is change this into multiplication. That's right. So we're going to take the first part of the division. It stays the same, but now the multiplication is going to change. Sorry, the division will change to multiplication, and that happens because we're going to flip or reciprocate the second fraction. So now instead of it being x minus 4 over x, it is now x over x minus 4. See? So from here, now that it's multiplication, I'm looking for any matches in the numerators and denominators. Just be careful, because what we don't want you to do is say there's an x and there's an x. That's what we do not want right there, okay? And so don't do that thing. Or even, I'm not saying it's worse, but it's about as bad. 2 and 4, you can simplify those. No, you cannot do that, okay? Don't simplify those. But what I do see is that I have an individual x here and an individual x there, which I can simplify. Now, of course, you would maybe say those simplify into ones. I'm just going to say they're going to simplify into phantom ones. And then what do I got left now? Well, in the numerator, I've got that x plus 2. And in the denominator, I have the x minus 4. And if I could think of any ways to simplify this further, I would, but I can't. So this is it. And again, this may be kind of weird, right? Like this looks kind of weird, but that's it. Let's add that in there, yeah. So if this was an equation, you'd have to declare, well, actually a couple. So right here at the end, x cannot equal 4.
This is not part of this, though, right?
No. Domain, right? Your domain.
We're working on
There's the
something else
domain.
now.
So 4, if it matters, it can't be 0 either. But, so don't make it 4 or 0. We'll get to that stuff, just not today, I think. All right, so this one, it's ugly. It definitely is ugly. And a lot of students, yeah, they look at it and say, hey, I quit. We don't want you to quit, okay, because we want you to focus on one part at a time. The first part, of course, that we want you to focus on is, well, having enough space to work. But take your numerator, all right? Take your numerator, separate this. Instead of making it one big fraction, we're going to change it into a division problem, okay? So just like we did on that last one, I got my numerator, and it will then be divided by the denominator. Let's see if I can copy this over here. There we go, boom. All right. Now, before I continue, what I would like to do is I have a trinomial in both the numerator and denominator of the first part of that division, in the dividend right here. I don't want that. I would like that to be factored. But before I even do that, just understand it is coming, but before I do that, I want to change this into multiplication. So that's what I'm going to do. So I'm going to keep that just the way it is for now, and I'm going to change this operation into a multiplication problem. So now the division will become multiplication, but that allows me to flip the second fraction there. So that's now x plus 4 over x minus 2. Okay? So we've come pretty far here. Again, was there any calculating involved here? Not yet. Not yet. There wasn't any factoring. It was just a process to change this from a complex fraction into division, now into multiplication. And again, we want it to be multiplication so that any matching factors in the numerator and denominator can be made into phantom ones. So now this is where I need to come through here, and I'm going to take the numerator and denominator of the first fraction and thank you, factor them. So I'm going to do the work over here, but again, just focus on one part at a time. Don't worry about doing the whole thing, just one part at a time. Split it up into smaller, more manageable parts. So I've got x squared minus x minus 2. Now my coefficient of the x squared there is 1, so I'm expecting this it should factor into two binomials with x's as the first term, right? But again, we got to look at -2. Our middle coefficient here is really -1. The two factors that add up to -1 that are factors of -2 would be -2 and +1. Because if you add these together, you get -1, but multiply, they give us the -2. So those two factors, since our leading coefficient is 1, become the other terms in these two binomials. It's a positive 1. Okay, so that's my new numerator. So I'm going to write that in. That's an x minus 2, and then times x plus 1. All right, but then we also had that denominator. We have x squared plus 3x minus 4. So again, I see my leading coefficient is 1, so I'm expecting this to factor into two binomials with leading x terms. But I need two factors of negative 4 that add up to negative 3. From what I can tell, that would be 4 and negative 1. Because, again, 4 times negative 1 is negative 4, but 4 plus negative 1 is 3, so that's the middle coefficient. Those are the other two terms in the binomials, positive 4 and negative 1. So let's get that written in there. Got an x plus 4 and then an x minus 1. And then we got the rest of that, right? So that's multiplied by that. I'm going to put it in parentheses just so it kind of matches. And that's over the x minus 2. Now that we have this, we're looking for any matches in the numerator and denominator. And so I see this x minus 2 in purple matches the x minus 2 in red, not color-wise, but value-wise. And then we also have in the numerator an x plus 4, put 2 marks through that, in red there. And then in the denominator, we have an x plus 4 in green. Now be careful because some students like x plus 1, x minus 1, they match. It's close. It's just they're not exactly the same. They need to be exactly the same. So this one is going to end up being simplified as x plus 1. Try to keep the colors the same, over x minus 1. Now you can put parentheses around those if you'd like, but I think it's pretty the way it is, so I'm going to keep it that way. Now hopefully you guys can see, just the last note on this problem here is, like if this was an x minus 4, x squared minus 4, you know, you'd have to split that up into an x minus 2, x plus 2 kind of situation. What I'm saying there is that you've got to look for all the situations that we've seen, especially the shortcuts. We don't want you to be factoring by grouping on most of these, right? Like, could I factor this by grouping? I could have, but again, it ends up with the same binomial. And so I am kind of taking a shortcut on these, not, well, I am a jerk, but not because I'm a jerk, but because it saves us a little bit of time, you know.
Can you go back for a second?
All right, so let's simplify this one then, but let's give ourselves a little bit more space. So this one, yeah, we do have the addition and subtraction on these, and what we would like to see here is the numerator and denominator, not with separate terms. We want it to be a full fraction so that, like, if you look at this denominator here, right? So let's first change this into a division problem, okay? I mean, it is just a different format, right? So let's take that and move it over here. It has the same value, so we're just changing the way that it looks. But this is divide, right? Between the 5/9 plus x.
Over 1?
We will, yeah. But yeah, so right here at this point, I'm just demonstrating what we have right now is two binomials being divided by each other, okay? And so technically what we should be doing here is kind of putting parentheses around these. Now, whether you do this right here like I've done, or whether you just work with these as numerators and denominators and then change the expression into a division problem is completely up to you, okay? I personally work within the fraction. I work in here first, and then I would change it to division, okay? But one good thing about changing it into this, maybe it helps you to separate the information. Okay, so here's what I mean by that. So I'm going to make this set of parentheses red, because what I want to do is make this one full fraction with a common denominator, okay? So, and then I'll rewrite it, but we could have written it as a fraction, which I will show. So this is 3/4 minus x, but really it's x over 1, okay? So it's 3/4 minus x over 1. What I'm missing here is a denominator of 4 in this second fraction. So what I would do is I'd multiply not just the denominator, but you need to multiply the numerator by 4. And again, this is really 4 divided by 4, which is 1, which is why it does not change the value of that term in the binomial. So now this would show as 3/4 minus 4x over 4, and that forced the denominators to match. What we would usually do here at this point is make the denominator the same, which it is, but then the numerators you can combine with the subtraction, okay? So that 3/4 minus x binomial now becomes 3 minus 4x over 4, okay? Now, why the crap would we do that? You'll see, okay? But it's gonna make the division, when it changes into multiplication, hopefully it will make it easier. And so what I meant, I'll come back to that, I apologize. So this one right here, right? 5/9 plus x, same idea. I'm gonna make it x over 1. I need a common denominator to make it a fraction, so I'd have to multiply not just the denominator by 9, but the numerator as well. So then, this becomes 5/9 plus 9 times x is 9x. 9 times 1 is 9. And then again, simplifying that into one full fraction, because we can share the denominator 9ths, becomes 5 plus 9x. Now even this, right? So this binomial I'm going to write as 5 plus 9x over 9. Some students are like, you know what, Sal, I really hate seeing the fraction like this. You don't have to like it, by the way. So if you would like to, you can write it as 9x plus 5. I guess that's what I was leading to. Because some students, they just prefer to have the x term first. But I don't care, so it doesn't bother me. Now this was still division, right? We didn't change that into multiplication, but now I am. Now I will change this into multiplication. So I've got my first part of the division, the dividend, 3 minus 4x over 4. I'm going to change the operation to multiplication, and that allows me to flip the fraction. So now it's 9 over 5 plus 9x. Okay, so we've gotten to this point, but we look now and we see, is there anything we can simplify? And I don't see that there is, okay? Again, don't get the idea that you can simplify the 4x with the 4 directly, not without splitting it up first back into this format. Or here, like the 9 and 4, I can't simplify there. So what I'm looking at is a situation where it's just straight multiplication, meaning I want to multiply this binomial by the 9 and the 4 by this binomial. I'm talking about distribution right here, okay? So in the numerator, let's see what we get from this. Just working in the numerator, split it up into separate parts. I'm going to have 9 times 3 there, which is 27. And then 9 times the negative 4x, which would be negative 36x's. And then in the denominator, same thing, but I'm distributing the 4. So 4 times 5, that'd be 20. And then 4 times 9x's would be positive 36x's. Okay, now again, this sometimes can become a test for us just to see how much math agony we can endure, because some students are like 36x over 36x, boom, I can simplify that. Don't, because they're within a binomial, so don't simplify that garbage, okay? But as far as I can tell, again, that's simplified. All this work that I did right here, some students, they like to do it inside the fraction. Again, so they would show the fraction 3 minus 4x over 4, and then the denominator would have been 5 plus 9x over 9. And then what they'll do is they'll take this, write it here, and then change it into multiplication, and then simplify from there. Which one's better? I don't know. Like I said, usually if I was to do this, I would probably do it this way. I would show the work this way instead of going through this route, but you see that we all come to the same conclusion there. Most students really, most of the students love this one a lot. Or love to hate it. So, on this one, what I recommend doing is just focusing on numerators and denominators. Don't worry about, hey, we're going to change this to multiplication. That will happen. Just don't worry about it yet, okay? So, here's what I'd like you to do, just for now. Just don't worry about the denominator, all right? We'll get there. We'll worry about it. Just not yet. Just not now, okay? So what I'd like to do is I'd like to focus on just the numerator for now. And what I would like to do also is take that numerator, and I would like to make the denominators match so that I can perform the subtraction, okay? So we did see problems like this in one of the previous sections where it said, hey, go and simplify this garbage. And And we've seen how to do that. Okay, so I guess I need a little bit more space there, but I need the denominators to match, right? So this is where I take one of the denominators and I multiply it into the other fraction, okay? So here's what I mean by that. I'm gonna take my x plus 1 denominator. I guess really I should put everything into parentheses, but I'm gonna multiply it into the other fraction, both numerator and denominator, right? So,
What?
so I got my x minus 2 denominator, right? I'm gonna multiply by the other denominator, x plus 1, right there. But again, if you do it to the denominator, you got to do it to the numerator as well. So that's the x plus 1. Okay. And as fun as that looks, I'm just going to keep it that way for now. We'll come back to it though. Because I'm going to take the x minus 2 denominator and I'm going to multiply it into the other fraction. Okay, both numerator and denominator. So if I multiply the denominator by x minus 2, which I am doing, I'm also going to have to multiply the numerator. Now, having done this and showed it, the orders are different. I've got x minus 2, x plus 1. Oh, I guess the orders are the same. My bad. So the denominators match, though, okay? Since the denominators match, they are the same. I don't care if they're the lowest common denominator. They're just common, at least. At least that allows me to actually perform the operation of subtraction. So the next step that I'm going to show in this problem, some students choose not to. Some students choose to do it, okay? But it's completely up to you. What I'm going to do here is I'm going to take, since we have a common denominator, in fact, what I'm going to do is I'm going to make this line bigger because I think I'm going to need it to be. But I'm going to take that common denominators, I'm just going to write it in. So that's a x minus 2 times x plus 1. Okay, because the denominators match, I can then subtract the numerators together. Well, what was the first numerator? I had x minus 2 times x minus 1. And then I also had x plus 3 times x plus 1. I guess it was red. Okay, now we've seen this before. We've seen it with addition and subtraction of with fractions, right? I don't have time to go into the example, but when you have common denominators with addition or subtraction, you just add or subtract the numerators. That's it. Okay, so I just took the two numerators, and even though I worked on them, and I combined them with subtraction. Now we do need to remember there is a denominator, but I don't worry about that yet. Okay, so what I'm going to do now is I've got to distribute these. Now I'm not even talking about the negative one right here. I'm just talking about FOIL, if you want to use FOIL with with these ones. Okay, so let's get started on that. Again, this is not going to affect the denominator, so I still have x minus 2 times x plus 1 in the denominator. And by the way, I'm going to keep these separated or factored, so that if I find anything that I can factor from the top that will actually make a phantom one with either one of these, that's good. You're welcome to multiply these and make a trinomial, but you're probably gonna have to split it up anyways, okay? So let's get started here. I got x times x, that's x squared. And I got x times negative 1, which would be negative, I'm gonna show the negative 1x. Then I got negative 2 times x, which is negative 2x's. And I got negative 2 times negative 1, which is positive 2. And that was fun. And that we're going to subtract, so I'm actually going to need the next part in parentheses here. See if I can fit it. So I got x times x, which is x squared. Then I've got x times 1, which is positive 1x. Then I've got 3 times x, which is positive 3x's. Then I've got 3 times 1, which is positive 3. So I barely fit that in. Well, that was fun. Yeah, definitely. So let's give ourselves a little bit more space here. See if we can stinking technology. Okay, so now I'm gonna take this and I'm gonna do even another step which you may or may not choose to show. I'm gonna show it though, because it's so much fun. And again, the denominator, none of this is affected by the denominator yet. Something may, but not yet. So x minus 2 times x plus 1. But I've got that right here. It's minus, so it's a -1, which we've seen before, right, with subtraction of these. Some students would say, well, can't we just combine these like terms? Yeah, but I'm going to wait. So if you want to do that, that's fine, but I'm not going to do that yet. Okay, so let's write everything in first. So I got, you know what, I skipped that. We'll come back to that. So from that distribution, I've got a -1x squared, and then I got a -1x, then a -3x, and then a -3, okay? So that's just from the distribution. We still have all the green terms in there, the x squared. If you want to show the 1, that's fine. And then you got the -1x minus 2x, and then plus 2, okay? So we did the distribution, then we did distribution, and then now that we have a fairly large expression, we are now looking to combine any like terms that are on this thing. And since we're having so much fun, it's good news. So on this one, we're still just in the denominator, but from this, so I got an x minus 2, still the denominator, right? Just keep that there. But in the numerator, what I see here is my 1x squared and my -1x squared. Those become a 0. They zero out. Now, on the other hand, though, I've got x's. I've got some x terms here. I've got -1x, -2x, -1x, and -3x. So in x's, that's like taking -1, -2, -1, -3, which I think I count as -7 x's. Okay, and then we have the constants of 2 and -3, which when I combine, I get -1. Well, so as fun as that was, however fun you think it was, that's just the start. Because, well, not the start. Really, we're not even. I feel like I want to give good news here, like we're halfway done. We're not, because we still got. Not only do we have to do the denominator, but then we're gonna have to switch this into a division problem, and then multiplication, and then look for simplification. Is it gonna be rough? I don't know. I don't know. Well, let's look at that denominator now. So I need the denominators to match, right? In the denominator. By the way, I got an x minus 2, x plus 1. Okay. So again, I need the denominators to match so that I can actually add these together. So let's go ahead and do that. I'm going to take my x minus 2 right there, and I'm going to multiply it into the other part there. Now, I'm not covering the numerator. You're welcome to do that, you know, if it's bothering you or if you get stuff mixed up. So that x plus 1, I'm going to multiply by x minus 2, but also the numerator times by x minus 2. Okay, but by doing that, then I now need to take the x plus 1 denominator and multiply it into the first fraction of the denominator, which is same as multiplying by x plus 1. Okay, and having done this now, I've got x plus 1 times x minus 2, x plus 1 times x minus 2. Yeah, those match. Okay, so again, is this more steps than you'd ever show? Perhaps. I can't guarantee that it is or isn't. I don't know. It just depends on how you want to do it. But at least my denominators match as x plus 1 over x minus 2.
You put this in a test?
Right. So now the numerator, again, I'm going to show this step. Would you actually show it? I don't know. But here we go. I got in the numerator, I got the x plus 1. I know it's getting kind of crowded in there, but it is what it is. It's how much room we got. So then we got an x plus 2. This one was plus. Don't forget we had a plus sign there. And then it was added to x minus 4 times. That was the x minus 2. Trying to keep my colors the same. Not just because it looks pretty, but hopefully it helps. So now that we've done that, I've got my same denominator of x plus 1 and x minus 2. By the way, the fact that these, like this denominator here, I know it's in a different order. Oh, it should be x plus 1, shouldn't it? Even though it's in a different order, we know when we change this to multiplication. I'm getting ahead of myself, but when we change it to multiplication, these are going to essentially become phantom ones with each other. We'll wait. All right. So now that we did that, let's go ahead and do some distribution. All right, x times x is x squared. X times 2 would be 2x is positive. 1 times x would be positive 1x. And 1 times 2 would be positive 2. So that's my first distribution. We are adding these together with the other distribution. So that's x times x, which is x squared. X times negative 2, which would be negative 2x's. And negative 4 times x, which would be negative 4x's. And then negative 4 times 2, which is positive 8. Now you notice on this one, I did not keep it in parentheses like this one in the numerator. That's because it's addition. And when we add terms like this together, I'm going to use the word terms, there's no need for distribution at that point. So really when I get this next part finished, that will have simplified the numerator for us because there's no need for distributing a positive 1. So let's just combine the like terms then, all right? Okay. Well, I got an x squared there and an x squared there. That would be 2 of the x squareds. So that's my x squares. What about x's? I got 2 x's, another x, that's 3 x's. Oh, take away 2. Now it's 1 x's, and then take away 4. That'd give me negative 3 x's. Then we got the constants of 2 and 8, positive. 2 plus 8 then is positive 10. There it is. Okay, now again, this trinomial should be simplified. So I'm just going to take that denominator and I'm just going to move it over into this next part of the fraction. Ah, that feels good, huh? Hopefully. But we got to, I don't know. It doesn't really matter when you do it, but I would like to look at that trinomial, 2x squared minus 3x plus 10. I just want to see if it can be factored, because if it can, yeah, and I'm assuming that it will. So if it can, then we're going to factor it. But since my leading coefficient is 2, I'm going to have to use factoring by grouping. So I take the leading coefficient, multiply it by the constant there. 2 times 10 is 20, positive, by the way. But I need 2 factors of 20 that can add up to negative 3. 1 and 20 don't work. 2 and 10 don't work. Negative 5 and 4 don't work. Yeah, so if this was just a 10, maybe we could get it to work, but it's 20. There's no 2 factors of 20 that are going to add up to negative 3, whether you choose 1 and 20, 2 and 10, or 4 and 5. And let's make those negative as well, just to make sure. Yeah, it still doesn't work. So this trinomial here just can't be factored.
Prime.
To me, it's prime. So to me, that part of it is good news, meaning once we get to the point where we can start making phantom ones and cross-simplifying, it should make that a little bit easier for us, hopefully. All right, I'm going to work my way down because if I make that any smaller, this stuff's going to fade off into oblivion,
Very easy to follow.
which maybe we want. So on this one, let's take that numerator, right? The negative 7x minus 1. And then we got the denominator of x minus 2. Do it slightly better. There we go. X minus 2 times x plus 1. But I'm changing this now into a division problem, which will lead into other things. But then my numerator there is 2x squared minus 3x plus 10. All over, I had it written as x plus 1 times x minus 2. Now, again, if the order of these makes a difference to you, like you say you want them to match, well, feel free to do it. It doesn't matter to me because I'm going to change this into a multiplication problem anyways. So let's get that first one written out. And let's change that division to multiplication by reciprocating that first fraction. So now I got a x plus 1 times x minus 2. That's my numerator now. And the denominator is still 2x squared minus 3x plus 10. All right. Now, we're so close. We're so close. Just don't give up yet. Well, I say yet, but maybe you gave up a long time ago. In any case, now I can find any matches in the numerators and denominators. I got an x plus 1 and an x plus 1. Boom. Those become phantom 1, cross-simplified. Same with this x minus 2 with this x minus 2. Boom. Cross-simplified. Now, again, we already checked this 2x squared minus 3x plus 10 to see if it could be simplified, but it cannot. So it's going to remain in the denominator, 2x squared minus 3x plus 10. and the negative 7x minus 1. Again, could you factor that out? You could factor out a negative 1 there. Sure, you could. But it's not really going to do anything in terms of this particular problem, so I'm just going to leave it alone. And we're going to call that good. To me, after seeing that last one, I look at this one and I'm like, yes, thank you very much. We're still going to simplify it. Now, yes, we do see addition and subtraction in both the numerator and denominator. Whether you do or not, they're there, but I will ignore the denominator. Okay, so let's look at that. Let's look at that numerator. I'm going to work below it so that once we get it simplified, then I'll just rewrite it back into the numerator there. But let's take a look at it. Okay, so I'm going to take it. I'm going to move it down so that I can actually work with it. There we go. All right. So from this, I need the denominators to be the same. They're almost the same. They almost look the same. They're not the same. This one is an m squared times n. This is an m times n squared. They are different. But what's missing? Well, in this first denominator, I'm just missing an n, right? This is an n squared. If I could have an n squared there, I'd be in good shape. So what I need to do is take that n and multiply it. See if I can do this right, but that'd be multiplied by n. But if you do it to the denominator, you need to multiply it into the numerator as well. Now, you could change this to n squared. I'm not going to. I just know that this is n squared, and I have to be okay with that because space, right? All right, that's nice. Now, this denominator has an n squared, just like we made the n squareds match, but the m does not match because it's not m squared. M squared would be m times m, so I would take that m and multiply it by m, but if I do it in the denominator, I need to do it in the numerator as well. Now, I'm showing it as 9 times m right there. Hopefully that's okay. Where we multiplied, whether it's in the front or back, doesn't really matter. But my denominator is now matched. So this is where I'm going to take that expression, right? The denominator's match is what would have been m squared times n squared, which is simplified. But then I take the numerators, right? So I had the 5n. This was being added to the other fraction, which now is 9m. Now, as much as you want to factor, because you love it so much, don't, because we just want to keep this at this point right here. I mean, there's nothing to factor, but keep this like this. Don't worry about factoring yet, okay? Now, let's go to that denominator. So I'm going to cover the numerator. And let's set this aside so we can work with it. See if I can, anyways. That'll do. Okay, so this one, same idea, right? We had m squared n, n squared. Same things are missing, just like this one was. So the first fraction is missing an n squared, right? So I'd have to multiply the n by n. So the 13 also multiplied by n. The second fraction, the denominator has just an m, but we want it to be m squared. So we're going to take that m and multiply it by m, and then we'll multiply the numerator by m as well. Okay, so we have forced the denominators to match, even though they don't look quite the same. But my denominator now is m squared times n squared. Now, the fact that these two denominators from the complex fraction here match, that is significant. Now, whether you know it's significant or not now, we will later. So what do we get in the numerator there? I got 13n. Now, this one was being subtracted, right? So I got subtract. I'll show the 1m. You don't have to show the 1 there. You can make it a phantom 1 if you'd like. But now that I've gotten to this point, I have one individual fraction divided by another fraction. Not any fraction addition or subtraction, right? It's just fraction divided by fraction. Now I'm going to take that fraction, complex fraction, I'm going to rewrite it as division of two fractions. So let's get that rewritten. Okay, and that was being divided. That's the big fraction line by the denominator there. Boom. All right, well, it's division, but we don't want this to be division. We want it to be multiplication. In fact, I'll take that back. So let's take that first fraction, which never will flip when changing this to division, but the division to multiplication. But let's take that division and change it to multiplication by flipping that second fraction. So that now it's m squared n squared over the 13n minus 1m. Now, at this point, since it is multiplication, I look for any matches in the numerators and denominators. I've got an m squared there and an m squared there, but I also have an n squared in the numerator and an n squared in the denominator. These go away as phantom ones. If you want to say they cancel out, that's fine. It's just that they become phantom ones. Now I will rewrite this, right, because that's what it equaled, as a new fraction, but hopefully a little bit more simplified. We got that 5n plus 9m that was left over from the numerators, because that, right, it didn't have a match here in the denominator. And then the denominator that was left over was that 13n minus 1m. And at this point, I'm going to change that one into a phantom one, just because we don't need it. And again, you may look at these and say, well, can we factor these? No, I don't see that they can. But you should check. You should always check. But yeah, that's good. All right, so we are looking to simplify this one. So let's give ourselves a little bit more space. But once again, let's just focus on the numerator first. So I'm going to just kind of get rid of that denominator so I don't have to even think about it. And if I saw this numerator, what I would notice is that each of the fractions, well, that's 3 different fractions. What I'd like to do is make it one individual fraction, right, like this. But what I also notice is that the one that's given is not being shown as a fraction. It may be useful to see it as a fraction like this, 1 over 1. Because now I can see that it's missing, I look at my x's, right? I've got more x's here than anywhere else, which means this x is also missing another x. Okay, so I'd have to multiply it by x. I'm not going to write that as x squared, but you need to know that it is. Okay, but if I do it to the denominator, I got to do it to the numerator. Same with 1 over 1. It's missing both x's, so I'm just going to show, I will show that one as x squared. But if I do it to the denominator, I got to do it to the numerator. So my common denominator then is just x squared, but that allows me then to combine all of the numerators, which is, I'm just going to show it as x squared plus 15x plus 56. Okay. And I would probably even look now at this point to factor out the numerator, because it can be. Of course, that's not going to affect the denominator of x squared. But I would look for 2 factors of 56 that add up to 15, and I get 7 and 8. Okay, so it now factors, because the leading coefficient of the x is a 1, phantom 1, it's just going to give us 2 binomials with the x's. Of course, we had it as positive 7 and positive 8. Okay, so that's about as much as I can do with that numerator. Now it's time to look at that denominator, and if you need to cover up the numerators, do that, okay? Let's get rid of that garbage. So in my denominator, I've got x plus x over 8. Again, it may be helpful to see that first x as x over 1, just so you don't make any mistakes there. But at this point, I see that the first term is missing an x. So I've got to multiply the 1 by x. I'm just talking about the denominator, and so I will have to apply it to the numerator as well. So what does this do for me? Well, it means that I now have a common denominator of x from the denominator. And now I've got in the numerator x squared, and then I've got that positive 8. Now this almost looks like a difference of squares, but 8's not a perfect square. And that's well, I can't think of any other way to simplify that. Okay, so I'm just going to tack it on to the next fraction. But at this point now, I'm going to rewrite this, but as a division problem, okay? So I'm going to take my numerator, which is kind of slanted there, that's okay, and I will divide it by the denominator. And now that we have it like this, I'm going to change the operation to multiplication. So the first fraction will stay the same, but this allows me to change the denominator, the divide, not the denominator, the divide sign into multiplication, and then I've got to flip this fraction. Okay, so now it's x over x squared plus 8. So the only thing I can see at this point, even in terms of factoring, is this x squared right here. Let me rewrite that. I'm going to rewrite it as x times x. And the reason that is because I have that red x in the numerator, and I can take that red x and pair it with one of the x's in the denominator. Essentially, that becomes a phantom 1. So again, I don't see anything else that can be simplified at this point. So I guess I can, but I will take the whole fraction and just kind of make it one full fraction. So let's take that numerator. That's all that's left from the numerator, those two binomials. And then in the denominator, I have an x and also an x squared plus 8. Now you could distribute the x there into the parentheses, but I don't see a need for it. And I believe that this is okay. This is a good way to leave that problem. So I'm going to clarify this. I think the problems on the assignment, like this would be a 1 right there. Which if it was, you would have just had an x plus 8 right here, which then would have been, it would have been able to, at this point, this would have been an x plus 8. And then you would have also made this a phantom 1. You would have been left with something like that. But that's not the way this one played out. But do expect to see something like that on the assignment.